Determine the current passing through each resistor for the circuit shown. So here's the circuit. I've got 2 batteries and 3 resistors. So I'm going to draw my currents. This is I1. Here's the junction. This is I2. That's I3. Set up my junction rule. I1 is going to equal I2 plus I3. Let me just stress, it doesn't matter what direction I draw the currents. I just need to draw them so that I can be internally consistent when I'm setting up my loop rule. That's the key idea here. So I've drawn the currents so that I'm internally consistent when I set up my loop rule. Okay, so at this point, let's set up the loop rule. I'm going to start with the outer loop. I'm going to go clockwise. So when I do that, that means V1. I'm going to write this symbolically first. It's going to be V1 minus I3 R3 minus I1 R1 equals 0. And just to be clear, it's positive V1 because I'm going, as I trace clockwise, when I go across the battery, I'm going from the negative terminal to the positive terminal. That's why it's positive 10 volts here. That's why it's positive V1, plus V1. And it's minus for the resistors because I'm going across the resistors with the current. That means there's a voltage drop. So that's why it's minus. And of course, I just went ahead and used Ohm's law there. But I can go ahead and put in my values. I know V1 is 10. I don't know I3, but I know R3 is 2. So this is 2I3. And R1 is 4. So this is 4I1 equals 0. Okay, so there's the outer loop. Now I'm going to do we'll just do the lower loop. So that's this one here. So if I do the lower loop, again, that's going to be V1, and it's going to be plus V2. It's going to be minus I2 R2 and minus I1 R1. And these signs are for the same reasons as before. I already explained these two because I'm still going the same direction across them. And up here, I'm going across V2 from the negative to the positive terminal, so that's why it's plus V2. And I'm going across the resistor with the current. That means there's going to be a voltage drop. That's why this is minus. Okay, put in the values that I have. 10 plus 15 minus 3I2 minus 4I1 equals 0. Okay. And I can, for the last loop, I can do this top loop. We'll call it the upper loop. And I've been going clockwise on all of them, so I'll go clockwise here. I don't have to, I could go counterclockwise, but just to mix it up a little, I'm going to go clockwise. I am going to stay clockwise. I guess that's not really mixing it up. But anyway, when I do that, this time that's going to be, I'm going across V2 from positive to negative. So that's going to be minus V2 minus I3 R3. But then it's going to be plus I2 R2 equals 0. And it's plus because as I go across R2, I'm going against the current. Since I'm going against the current, that's a voltage gain when you go across a resistor. If you go across a resistor against the current, it's a voltage gain. That's why it's plus down here. So put in the values. This is minus 15 minus 2 I3 plus 3 I2 equals 0. Okay, now, obviously the goal is to solve for the currents, but to take it a step further, my personal approach, I've got the loop rule. So I just usually pick one of the currents and solve for the others in terms of it. So in this case, I've already got I1, So I'm just going to solve for I2 in terms of I1, and I'm going to solve for I3 in terms of I1. By the way, I didn't need to do all 3 loop rules. I just went ahead and did them all so that you could see me go through the process. I'm actually only going to need 2 of them to get the answer, but I can use the third one to double check my answer. Okay, so let's solve here. Let me, oops, didn't mean to do that. Let me do this. So I'm going to solve this equation, the outer one, for I3. So if I solve for I3, let's see, that's going to become 10 minus 4I1, that's going to equal 2I3, and that means I'm going to have 5 minus 2I1 equals I3. Okay. And I'm going to take that, I'm going to be putting that into my junction rule. Okay, then for the lower loop, solve for I2. 10 plus 15 is 25, minus 4I1 equals 3I2. Solve for I2, so that's 25 thirds minus 4 thirds I1 equals I2. Okay. So now I can say, okay, I1 equals, I put in what I2 is, that's 25 thirds minus 4 thirds times I1, and then I3 is 5 minus 2 I1. Okay, get the I1s all on one side. So I'm going to have I1 plus 4 thirds I1 plus 2 I1. It's going to equal 25 thirds plus 5. Okay, so now get common denominators. So I'm going to factor out the I1, and then my common denominator is going to be 3. So this is going to become 3 thirds plus 4 plus 6 all over 3. So this was 3 divided by 3. That's just 1 I1. That's where that came from. The 4 thirds, where we see that, and 6 over 3. That's 2. So that's all I did there. And then here, this is 25 plus 15 thirds. Okay. And so the thirds cancel. These cancel. And this is I1 times, this is 13 I1 equals 40. And so I1 equals 40 thirteenths, which is approximately equal to 3.077 amps. Okay, so there's I1. So I've got I1. So now I just solve for I2, and that's easy to do. I can solve for I2 and I3. I just use the formulas that I got earlier. Let me just go ahead and circle both of these. I'm going to use those two formulas to go ahead and solve for I3 and I2. So solving for I2, so it's going to be 25 thirds minus 4 thirds. I1 is 40 thirteenths. That's going to equal I2. Plug this all into the calculator. And I get that I2 equals 4.231 amps. Okay, and finally, let's solve for I3. That's going to be 5 minus 2 times 40 13ths. That equals I3. Okay, so that's and I get that I3 equals negative 1.154 amps. Okay, so notice I got a negative answer. That just means I have the wrong direction for I3. The answer that I would enter into WebAssign would be positive 1.154. You can't enter a negative current. Currents by definition have to be positive. Okay? It's just that I drew the current going the wrong direction. That's why it came out negative. Okay? Now the other thing is, if I say instead of solving for I1 first, I'd solved for I3 first, and I got this negative. Okay, I would have to use this negative answer throughout the rest of my calculations. That goes back to what I was saying about when I draw the currents, I need to draw them just so I can be mathematically consistent, internally consistent with all of my calculations. And this is what I'm talking about. Since this came out negative, I would have to use it in all, as a negative, I would have, in all the other calculations. And indeed, if you take this number and you plug it up into here, you'll find you use these numbers. So in other words, 4.231 plus negative 1.154 equals 3.077. So just to stress, again, one more time, if you come up with a negative current, you need to keep it as negative for any additional calculations you do. But when you enter the answer into WebAssign, you enter it as a positive number.